Okay, let's start out by looking at what we would do if we already had our half reactions. We just want to balance it out, okay? Because we're getting ready to learn how to do this. If I'm just giving you a chemical reaction, I say that it's a redox reaction, and you just need to decide how to balance it. But we're taking it in steps. Okay, so writing a balanced redox reaction given balanced half reactions, what would we do? Well, if you're given a balanced half reaction, we're going to multiply the half reactions so that the number of electrons lost during oxidation is the same as the number of electrons gained during reduction. What we want is we want to have the same number of electrons on the reactant side as on the product side between the two half reactions. And then we're going to add them together into one reaction and cancel out common terms. Now let's do an example. Hopefully it'll make even more sense. Our first example, I have aluminum with a 3+ charge plus 3 electrons. I already put the electrons in there for you, and it's going to give us aluminum. And then the next example, we've got 2 bromide ions turning into Br2 and 2 electrons. Well, I notice my electrons, I've got 3 here and I've got 2 here. So what we need to do is make those numbers the same. Well, they're not the same, so I can multiply this top number by 2, and I can multiply all the numbers on the bottom by 3, so that I'm going to have 6 electrons on the reactant side and 6 electrons on the product side. But if I do that to the electrons, I've got to do it to everything else in that half reaction. So what that's going to give us, I shouldn't do an arrow. Let's use a different symbol there. Okay. So what that is going to equal is 2 Al3 plus 2 times 3 is 6 electrons yields 2 aluminum atoms. Okay, down here I end up with 3 times 2 is 6 bromide ions. Gives us 3 bromine molecules, Br2, plus 6 electrons. Okay, now I can look at what's on both sides and cancel them out. So I see that I've got 6 electrons on both sides. I can cancel those out now. Look for anything else that could be canceled out. I don't see anything that's identical on both sides. Al3 plus turns into Al. Okay. Br minus turns into Br2. So I don't see anything that could be truly eliminated. So I'm just going to rewrite the equation combining everything together. Reactants are 2Al, 3 plus 6 bromide ions. And I got rid of the electrons. Yields 2 aluminum atoms plus 3 bromine molecules, and again we got rid of the electrons. Let's do another example and see what we can do here. If you feel comfortable, try it yourself and then see if you get the same answer. Okay, I see that I have 6 electrons and 2 electrons. Well, I know that I can multiply 2 by 3 to get 6, so I'm only actually going to multiply the top reaction. So I'm going to multiply that by 3, and that's going to give me, and I'm just going to write it down below. This is another way you can show your work. That'll give me 3 Mn2 plus 3 times 2 gives me 6 H2O. Now I see that I've gotten to the arrow. Well, I don't want to go there yet because I've got all this down here that I need to write down as reactants. So I'm going to start there. Add Cr2O7 2 minus plus 14 H plus 6 electrons. Now I'm ready to go to the product side. Don't forget you're looking at the top reaction and the bottom reaction both. So I'm going to start with the top one. MnO2, and don't forget, we just multiplied by 3. The whole top reaction is multiplied by 3. Plus 3 times 4, it's 12H plus. Of course, we're adding plus 6 electrons. Plus, and then I have 2 Cr3 plus 7 H2O. All right, and we said we can cancel anything out that's identical on both sides, and I mean identical in charge and number, and what the symbol is. So I see Mn2 plus is the first thing I see on the left. I don't see Mn2 plus on the right in any form that's identical, so I can't cancel that out. I see H2O on the left. I do not see H2O. Oh, I do. I see H2O on the right. I've got 6 H2O on the left, and I've got 7 H2O on the right, which means if I canceled out 6 of those, I've got 1 left. I've got 1 H2O left on the right. Okay, got 1 of those. All right, next thing I see is Cr2O72 minus. I don't see that on the product side. 14H plus. Well, I don't see 14, but I see H plus. I see that I've got 14H plus here, and I've got 12 here. The difference is that I'm going to have 2H plus on my reactant side. And then, of course, our 6 electrons are going to cancel out. Now let's write down everything that I did not cross out. So I have 3 Mn2 plus Cr, that's not a G, that's supposed to be a Cr2O7, 2 minus charge, plus, of course, our 2H plus yields 3 MnO2 plus 2 Cr3 plus 1 H2O. I really don't need that coefficient of 1. It's just plus H2O because there's only 1 of them. All right, and that's it for our examples of combining balanced half reactions. We're going to learn how to write a balanced redox reaction just given the reactants and products next.